Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream, and we're back being fully live again this week. Here's our topic, which is OCS User Security. Now, OCS User Security is a feature that you can take advantage of that allows you to determine what certain users have access to in terms of the actions they can perform. And you can tie that to push buttons and data objects and all kinds of things. Now, a lot of you have, maybe over the years, have been kind of rolling your own user security with the OCS, and that's great. We just wanted to show you the built-in user security so you could decide if you might want to take advantage of that on your next project. Now, this is the part of the program where I normally bring in our product manager, Casey Gardner, but Casey's just recovering from a really nasty throat and he's just getting his voice back, so we're going to wait for another week. All right, let's go ahead and get started. Here's how we're breaking down our topic for today. What do we mean by user security? We'll start with that. We'll talk about user security as it relates to local user access versus WebMI user access. We'll talk about setting access level on individual objects. We'll talk about the method you use to input user credentials into your project so that later on, end users or operators can use those credentials to log into the machine. We'll talk about what happens at runtime. What's the operation like? What kind of status feedback do you get based on which operators are logged in? And of course, as we always do on Tuesdays, we'll give you plenty of demonstration. What do we mean by user security? So Cscape offers multiple features that are related to security, and a lot of you are probably thinking of project security. That's the feature where you can actually protect your intellectual property by preventing unauthorized access to your CSP program and unauthorized uploads, for instance, from the OCS, again, in an effort to protect your intellectual property. But what we're talking about today is something different. That's user security, the ability to restrict user access to certain screens and certain objects at runtime. And then user access levels are granted based on the login credentials that you assign to users. User security can be applied in kind of two different ways. First of all, you can think about user security as it relates to the local operator interface or the local OCS, the operator who's physically next to the OCS who's touching the screen. User security relates to that. You can also talk about user security as it relates to WebMI for remote access, for those who are accessing the OCS from a web browser. For those of you who aren't aware of it, WebMI is a feature that's available in just about any OCS that allows you to remotely monitor and potentially control any OCS from a web browser. XL Series and XL Prime can support user security as it relates to both local operator access from the touchscreen as well as remote WebMI access. Our lower end products, like the XLE and XLT and the micro OCS families, they only support WebMI-based user security. For those, you'll have to continue to kind of roll your own local user security, but that's not that difficult. It's just not what we're going to be talking about during today's topic. So how does the OCS control user access? A lot of you may be used to HMIs that you've used in the past, which use kind of a page level user security or a page level access model. And the only problem we see with that model is that you could end up creating a bunch of almost identical screens that just have different levels of security. With the OCS, we thought it was a better approach to go object-based. In other words, every object that has an action can be assigned an elevated security level or elevated access level, which limited which operators would be able to operate it. What is an object that has an action? Well, examples might be a push button, where you push the button to start or stop something. Maybe a screen jump object, where you push the button to change to a certain screen. It could also be something like an editable numeric data field, where you push that object to change the value maybe of a key process set point or something. In order for an operator to actually operate any of these objects which have a elevated access level, their own access level that they've been assigned has to at least meet that of the object. If it does, it'll operate just like normal. If it doesn't, they'll be restricted from accessing it. How do you set the access level on individual objects in Cscape? Well, we're talking about graphical objects here, push buttons, numeric data objects, etc. So of course you're going to be doing that from the graphics editor. And every individual graphics object that you put on the screen, if it has an action to it, you'll have the ability to set an elevated access level. Now you don't have to do it on all objects. As a matter of fact, on most objects, probably the access to all operators is going to be basically the same. But on certain key objects, or maybe on certain key screen jumps that you want to effectively limit from an operator standpoint, those are the ones in which you're likely going to be elevating the access level. So how do you do that? After you've placed that object on the screen, you double click on it to pull up the configuration dialog, and you'll find, since that object has an action, that you'll see an access button. You then press the access button, and up pops a pop-up box that allows you to set the access level between 0 and 7. 0 basically is the least restricted, or no restrictions at all. Every operator will have the ability to operate that particular object. Or you could assign up to a level of 7, which is the most restricted, and of course you can go anywhere in between as well. For those of you who are thinking about replicating kind of the screen level access, you can do that simply by increasing or elevating the access level of a jump button. And then in order to use that jump button to navigate to that screen that you want to effectively protect, you've done that by increasing its access level. Runtime, as I mentioned before, when an operator presses an object with an action, one of two things is going to happen. First of all, if his access level is sufficient, in other words, it's equal to the object or greater, then when he presses that object, it's just going to operate as normal. However, if his access level is too low, then when he presses that object, he'll see access denied. Let's say it's a editable numeric object. He's still going to see the current value of that object, so that's informational for him. He just won't have the access level to be able to change that value. Okay, next let's talk about user credentials, because we've talked about setting elevated access levels for certain objects on your screens, but how do we actually get the user access levels into Cscape? So again, from the graphics editor, this time we're going to go to the config menu and we're going to select the option for user security configuration. Once we've done that, we now have a dialog that appears that allows us to configure up to 255 different sets of user credentials. Every user credential consists of a username, which is an alphanumeric field with up to 16 characters max, and a password, which is alphanumeric also up to 10 characters. When we say alphanumeric, we mean numbers and letters, no brackets or exclamation points or those sorts of things. Generally, I would recommend that for each of these user credentials that you want to enter in, these sets of user credentials, I recommend you go ahead and just hard code those in. You could assign variables to those, which makes a lot of sense, except WebMI requires constants to be entered in. You don't have the ability to use variables for your user credentials if you're using WebMI. And WebMI is a pretty valuable feature. And keep in mind, you can enter up to 255 sets of credentials. So you can have a whole bunch of credentials for operators that have the same access level, but you can hand out, or your end user can hand out, unique user credentials to each of those guys so they're not sharing each other's credentials, for instance. So when you decide to go ahead and add those credentials or maybe edit some existing ones, it's really just a matter of pressing the appropriate button for edit or add, etc. And then I recommend hard coding in between single quotes the username and the password. When you first go to this original dialog for adding the credentials, you'll see that there is a default set of credentials called default user with a password of default. So I typically just leave this one in and then just add additional ones to it. That's the approach I usually take. And then of course with each set of credentials, you set the access level that that particular set of credentials has. So we've done two things so far. The first thing we did was on key graphic objects that had an action, we elevated the access level. The next thing we did was we went ahead and added in a number of sets of user credentials, as many as 255. The last step we need to do is we need to give the operator some way of logging in at runtime. And the way we do that is by adding a system login object. How do we do that? We use the password object, which is an object that's been around a long time. I've got it highlighted there on the screenshot. Once you've pressed that icon, you drop a password object on the screen, and then you double click on it to go into the configuration dialog. At the very bottom, you'll notice that there is a pull-down list that allows you to select an object type. And you're going to want to select an object type of user access. So by doing this, now your password object becomes really a user login object. Okay, and then you can go ahead and manipulate the font sizes, manipulate the legend, for instance, resize the object, just get it the way you want it once you've done that. One last thing you have to do with the system login object is you do have to assign it a double integer variable, even though that double integer variable really doesn't do anything. It's just that there's a variable, there's always been a variable assigned with the password object, and we decided to leave that in there. It's always going to have a value of 0, so just be aware of that. So we went ahead and changed the key graphics objects. We went ahead and added our sets of user credentials. We've added an object somewhere in our project on one of the screens so users can log in. The last thing we're going to want to potentially configure is way back where we added our user credentials, and that is status variable. If we're not using WebMI, we can assign a status variable that in the end is going to be 10 words long. The first 2 words is going to tell us in seconds how long the current user has been logged in for. The next 8 words are going to tell us in ASCII what that username is. And then if we go ahead and prepare the project for WebMI like I recommend, we'll select the WebMI support checkbox, and then our status goes from 10 words up to 50 words, where we not only have the local user information I just talked about, but we also have 4 sets of concurrent WebMI logins that we can monitor as well. Because remember, with WebMI, you could have multiple people logging in simultaneously, in addition to the operator for that matter. Let's go ahead and pull up Cscape and let me demonstrate this for you. Here's my Cscape project that I've created. I'm going to go ahead and head straight for the graphics editor because almost everything we're doing here with user security is done from the graphics editor. So I've just got this home screen I've created here, and really the whole point of this project is to kind of demonstrate some of the different techniques you can use with user security to achieve the result that you're looking for. Now let's start with this group of 3 jump objects. Now, you know, a jump object is an object that an operator will press, typically to change screens. So I've created a jump object to go to a screen to allow the user to log in. I mentioned earlier, you don't need to elevate the access level of a lot of your objects, whether they're jump buttons or push buttons or whatever the case may be. Just the key ones is what you typically would need to do. So in the case of this jump button, you'll notice that it has an action. All jump buttons do. So therefore it has an access button. And by pressing it, you'll see I've left the access level at its lowest or at 0. Because we want everybody who presses that button to have the opportunity to either log in or log out of the machine. So there's no reason to elevate the security of that. On the other end of the spectrum is the machine setup jump button. As you can imagine, you don't necessarily want everybody being able to have access to the machine setup screen. So in this case, when I select access for this jump button, I've decided to elevate the access level above 0 up to 4, about midway. There's no one right answer here. You just need to design the different access levels for whatever it is you're trying to achieve. So I decided to use kind of a mid-level access level here. So any operator with access level of 4 or higher will be able to access the machine setup screen. And then in the middle here is this machine status screen. This is a screen that I'll show you in a minute. It'll show you what's going on with the machine. Is it running or not? What's the process look like? Etc., etc. And really, there's no harm in allowing just about any operators to see that information. You just don't want them changing anything critical. If they don't really know what they're doing, you don't want them changing machine set point. You may not even want them starting or stopping the process, for instance. So again, I've decided not to protect or elevate the access level above 0 for this object. I'm going to go ahead and let anybody switch to the machine status screen. Now, what's the machine status screen look like? Well, I'm going to use my handy-dandy simulator pointer here and switch to it right now. So I've got a number of objects on this demo screen, everything from bar graphs and analog meters and a pilot light that don't have an action. At runtime, when I press these objects, nothing happens. They're there to provide feedback, not to actually do anything other than that. However, I also have this numeric data object, which is editable, as well as a start process toggle switch that do have an action here. And for these, I went ahead and elevated the access level because I just don't want any operator to do this. So under start process, that toggle switch, I've made the access level for that guy 3. And then for the key process set point editing, I've set that access level up to 4. You'll get an idea now that you have the ability to design a single screen, and just by tweaking the access level on different key objects on the screen, you can have different things available to different operators after they log in. Okay, so that's what I've designed here. All right, so that's all the changes I've made to key objects to elevate their access level, and others I've left alone. Next, let's take a look at entering in user credentials. So for that, again, staying in the graphics editor, we go to the config menu and user security configuration. And you'll see here I've entered in really a very modest number of user credentials. I just added 4 user credentials to the default one. Okay. Editing them is very simple. You either hit the add button or the edit button, and you have the ability to type in the username and the password, which are alphanumeric fields, and the access level. Again, I recommend you hard code those, and therefore you're going to need to put them in between single quotes because they are effectively alphanumeric strings, okay, that I'm entering there. All right, and I did also choose to take advantage of the status feedback and take advantage of WebMI. So I have a user status variable, which contains information I can monitor for the users currently logged in, as well as how long they've been logged in. Then I've decided to support WebMI, and also I've bumped the user timeout from 5 minutes, which is the default, up to 15 minutes. So this is the time in which the OCS will automatically log out an operator after they've logged in. So that's configuring the user credentials. Let's head back to the main screen, and I want to show you a couple other things. Well, let's just show you one other thing, and we can do that from here. Let's take a look at kind of a teaching screen that I put on the unit here. And this is really, I put data fields that show you what you'll actually see when you look at the status information for the user. So you'll see the user name as well as time in seconds since they've been logged in. And you see that for both the local user as well as up to 4 concurrent WebMI users. Okay, so that's what I wanted to show you from a configuration standpoint. Now let's go ahead and take a look real time at the OCS, and I'll show you how things go at runtime. Here's the home screen. I'm just going to go ahead and hit the user login screen. You'll notice from looking at this object that currently there is no user. Okay, nobody's logged in. So I'm going to go ahead and log in. Okay, and I'm just going to go ahead and use the novice login here. Now keep in mind it is case sensitive, the password field. So I've got to enter it in properly. And then I'll also enter in the password. Now if I've done that correctly after pressing login, I see the username is now novice. Great, terrific. Let's head back to our home screen and see what we can do, or what we can't do as the case allows. Let's go do some machine setup. Nope, that's not going to work because I don't have, as the novice, I don't have appropriate security level to be able to access that screen. That jump button has an elevated access level. Well, how about the machine status screen? Hey, I can access this one. Terrific. And I can see what's going on. I can watch the process change. I can see the system's running. So there's some value in me looking at this screen. But if I actually want to go in and kind of stop the process by toggling the switch, that's not going to work. And even if I try and go in and change the set point, no, that's not going to work either. I don't have an adequate level of access to be able to operate those particular objects. Let's take a look at my teaching screen and see what the status looks like here. So here we can see that I have a logged in OCS user locally there named Novice, and I've been logged in for about 65 seconds now. Now I'm going to show you what happens when I log in remotely using WebMI. So let's head back to our PC. I'm going to head and get out of the graphics editor here, and I'm going to fire up my Chrome browser. Okay, because remember, WebMI is the ability to remotely monitor and potentially control an OCS from a browser. So I'm going to go ahead and navigate to the IP address of this particular OCS. It's going to ask me for a username and password. And this, I didn't have to configure anything here. That's just built into WebMI. When you go to access WebMI by typing in the IP address of the OCS, automatically from your browser, you're going to get this pop-up window. Okay, I'm going to give it a fairly high access level from the set of credentials that were programmed in. Username of setup, and there's my password. There we go. So once I accept the license agreement and hit continue, I basically have the same view that an operator would have. I'm looking at the initial screen. And let's go ahead and call up a window that shows what's happening on the OCS screen directly. So you can see I'm looking at a completely different screen remotely than my operator is looking at. That's because I've set up WebMI not to be synchronous, not to synchronize with the exact same display of what's on the local screen, but to have the ability to look at things independently. Okay, so on the local screen, since I'm sitting right here, I'm going to go ahead and go back to the machine status screen, just so you can see what's going on the machine there. From here, from the WebMI, let me go ahead and go to machine setup, see if I have access to that. I do. Okay, I've got a high enough access level I can do that. The only thing I have here is this kind of ominous looking self-destruct button, and I think I'll decide to skip the self-destructing at this stage. Let's go back to our home page and go to the machine status. And sure enough, I'm looking at the same information that my operator is currently looking at. But when my operator tries to edit that field and is denied because of my security level, I have the ability to go ahead and change this process set point. And if I wanted to, I could even toggle off the process. And you can see I, as the local user, you can see what I'm seeing there too. I can see the results of what's happening remotely, even though I didn't have the ability to do that myself. So while we're logged in remotely here over WebMI, let's go ahead and pull up that status screen again. This time you'll notice, hey, there's two users logged in. We've got the novice who's been logged in for 4 minutes or so, and we've got WebMI user number 1 or setup, okay, which has been logged in for 127 seconds. Let me show you one more thing before we wrap up here, and that is I'm going to go ahead and close my browser here. And then I'm going to go ahead and call up the OCS in full screen, go back to the status screen here, and you'll see that what's going on here, the setup WebMI user is still logged in. Why is that? Well, I've set a timeout of 20 seconds for WebMI. So that means 20 seconds after I close the browser, the OCS is going to go ahead and log off automatically that WebMI user, and you can see on the screen that's exactly what happened. I think that's pretty much what I wanted to show you today in terms of how to configure user security in your project and what it looks like once you do that. Let's go ahead, and I want to cover a couple of things here as we wrap up. The first thing I want to mention is you still have a couple more minutes if you have any questions to type those in the chat section if you're watching live. If you're watching on replay, of course, just give us your questions in the comment section and we'll get those answered when we can. We're here every Tuesday at 2 o'clock with another technical topic. On the weeks where we can't be fully live, we will stream live a pre-recorded video and be standing by to ask questions as we do it. So we'll still be live to answer your questions. And of course, all our videos are available to watch on replay. And again, we're looking for your questions in the comment section in that case. Next week, we think we've got a great topic for you, and that's all about the Cscape shift register instruction. This is a great instruction. It has a million uses. Some people get a little bit intimidated because there's quite a bit of setup required for this particular function block because there's a lot to it. But I think once you're done with next week's topic, you'll be completely comfortable, if you're not already completely comfortable with that particular object. One more thing, and that is if you haven't already subscribed to our channel, don't hesitate to do it. I'm not sure why YouTube calls it subscribing when it doesn't really cost anything, and we know how much our other subscriptions cost us. But if you subscribe to our channel and you choose notifications, you'll be notified every time we go live, as well as every time we drop a new video on our channel. Okay, so until we see you next week, thanks for joining us and stay safe out there.